Hi guys, in this video we're going to be learning about logical operators. Logical operators allow us to construct more complex logic into our code. We've already looked at conditional statements and using relational operators in a previous video. So let's recap quickly on that. I'm going to create a variable int score equals 60 and I'm going to do if score is more than or score equals 60. We're going to print out the score is 60. Else, I'm going to print out the score is not 60. So very simple print statements. We're going to check if the score has a value of 60, and if it does, we're going to print out a specific message, and if it doesn't, we're going to print out a different message. So let's run the application. And it prints out the score is 60. So this if statement resolves to true, meaning that the content of the if statement will be executed. So the score is 60, so this resolves to true, meaning that we will print out the score is 60. If I was to change that to 70, this would be false, meaning that it would go to the else part of the if statement and print out the score is not 60. So let's run that, and you can see the score is not 60. Now let's try using logical operators. So I'm going to delete this code and I'm going to declare three variables. So we're going to have int a equals 10, int b equals 20, and int c equals 30. So we have three variables a, b and c with a value of 10, 20 and 30. And we're going to require that certain conditions are met before we print out a statement. So let's say what we want to do here is print out that the value is within limits, so any arbitrary message, we just want to print out a message if a is more than a certain number and b is less than a certain number. So we can do that with logical operators. So if a is more than 12 and b is less than 30, we're going to print out, so system out print line, values are within limits. Otherwise, we're going to print out false if statement. So what exactly does this double ampersand mean? Well, the double ampersand here is our logical operator. There's three logical operators in Java. Double ampersand meaning logical and, the two vertical bars, or the also known as the pipe symbol, and that's just above the backslash on my keyboard. This is a logical or, so now we're saying if a is more than 12 or b is less than 30, print something out. And the final one is the exclamation symbol, and that basically reverses whatever particular conditional logic you have, and we'll use that in a later example. I'm going to return this to our logical and. We're saying if a is more than 12 and b is less than 30, print out that the values are within the limits. Now we know that a is 10, so a is not going to be more than 12. 10 is not more than 12, so this resolves to false, in which case it doesn't perform the right hand side of this logical and, simply because a logical and requires that both the left hand side and the right hand side are true. Because of the fact that this one's false, it will essentially short circuit and not perform the right hand side, because even if the right hand side was true, it doesn't matter. This logical operator would still resolve to false. So this statement would still resolve to false anyway. If I change the value of a to 15, then 15 is more than 12 and b is less than 30. So if I was to run that, you can see that the values are within limits because this resolves to true. If I was to return it to 10 again and run that, we get false if statement because, as we said, if a is 10, 10 is not more than 12, but b is less than 30, which is 20. So 20 is less than 30, but because of the ampersand, we require that both the left and the right hand side are true. If we wanted this to resolve to true without changing any values, then we can do that by using a logical or operator, the two vertical bars, also known as the pipe. So now we're saying if a is more than 12, which it is not, but this time we don't short circuit because it's an or symbol. So we're saying if either this side is true or this side is true, then the whole condition would resolve to true. In other words, we'd then print out values are within limits. So now you'll note that we haven't changed the values, even though the previous time we ran the application we got false if statement. But if I was to run it now, we'd get values are within limits. Because A is 10, and 10 is not more than 12, and we know that that particular part of the if statement resolves to false, but because of the fact that we're using a logical OR, we're saying that if either the left-hand side or the right-hand side is true, print this out. And we know that B is 20, and we know that 20 is less than 30. So this will be true. Now let's move on to the third logical operator, which is not. In other words, an exclamation mark. So what is that actually going to do? Let's change this back to a double ampersand. So this is our logical AND operator. And if we remember from before, this will resolve to false because A is not more than 12 at this point. It has a value of 10. 10 is not more than 12. So this entire if statement resolves to false, meaning that we print out false if statement. Let's run the application and you can see false if statement. But what we can do is take this particular condition here with our relational operator of more than. So what we can do is reverse it, essentially making it to be the opposite of whatever it is. So I'm going to put it in brackets. Currently at this point this would run exactly the same if A is more than 12 and B is less than 30. But what we can do now, because of the fact that it's in brackets, is we can put an exclamation mark in front of it. And this will basically say that if A is more than 12, which we know it's false, this would resolve to false within the brackets. But because of the fact that outside the brackets we're using a not logical operator, this would essentially reverse it. So yes, this will be false, but this as a whole would be true. And now we have true on the left hand side of the logical and true on the right hand side, meaning that values are within limits. So if I run this, you can now see that it's printed out values are within limits. We haven't changed the values. A is more than 12, still resolves to false, but because we're essentially reversing it with our logical operator here, it will print out values are within limits because this side of the ampersand is true and this side of the ampersand is true. Another thing that we can do here is chain logical operators within an if statement. So what do I mean by that? Well, let's remove this logical operator here and we'll remove these brackets. So now we're back to A is more than 12 and B is less than 30. And if we run that, we know that that is false because, as we said before, 10 is not more than 12, meaning that we stop right there and we don't perform the right hand side of the logical AND operator. But what we can do is use multiple logical operators within a single if statement. So right after this one, I'm going to do logical OR C is less than 40. And we know that C is less than 40 because C has a value of 30, and 30 is obviously less than 40. So if I was to run this if statement now resolves to true because values are within limits has been printed out. As a whole is now true. And this is down to the way that the code is executed. So yes, this resolves to false, and if we were to evaluate that as a whole, it would evaluate to a Boolean value of false. So now we have on the left hand side of the logical OR operator here, we have if it's false or C is less than 40, which resolves to true, then the entire if statement will be true, meaning that it prints out values are within limits. So you can use as many logical operators as you want within an if statement. So from a precedence point of view, the logical AND and the logical OR don't necessarily have precedence over each other. It's just that they're run from left to right. So for example, if I was to swap these around, so we're going to use a logical OR there and a logical AND here, then now we're saying if A is more than 12, which is false, or B is less than 30, which is true. So this as a particular operation would resolve to true because we're using a logical OR. So we'd have true here and C is less than 40, which is true. So we have true and true, meaning that this whole if statement would resolve to true, printing out values are within limits. If I was to run that, you can see that values are within limits. However, if I was to use a double ampersand here, so we have a double ampersand there and a double ampersand here, this would resolve to false because now we're saying if A is more than 12, which it isn't, and B is less than 30, so this as a whole would resolve to false. C is less than 40, but it doesn't matter because of the fact that this resolves to false and we have a double ampersand here. So as we said before, it essentially short circuits and says, well, the left hand side of this double ampersand is false, so there's no point in trying to determine whether or not C is less than 40, because even if it's true, this side is false, meaning that the entire if statement is false. So if I was to run the application now, we get false if statement. So that's everything for this video. We will come across logical operators again in a future video, but for now, thank you very much for listening. I really hope you found it useful, and if you did, don't forget to leave a like and subscribe.